Okay, all right. Okay, the last, okay, I should move, right? The last topic is the SEM, okay? So we have about 1 hour and 15 minutes, no, 1 hour and hour and a half. Yeah, pretty good. Okay, so, all right. Well, actually, this is the one of my expertise in the IT. I've been teaching the SEM course for uh, close to 10 years by now. So I'm pretty much comfortable with this topic. And first time, I taught this topic. I was specifically focusing on the separate software outside of the R, but I gradually, incorporated what R can do. And right now, actually, my focus is more on the integration between a software called the M Plus. Have you heard of it? That is the super, super excellent SEM software. Probably the best software you can find on Earth in terms of the SEM analysis. So it can do so many different things, and there are so many things that the other SEM software cannot do. And then good news is that someone wrote a package on R to sort of integrate M plus and R. So essentially, M plus control. The R control M plus. R writes the M plus syntax externally and runs it and reading the result or something like that. And then we can manipulate the results that we are getting from the M plus right on R. Again, many cases, we need to run many different models and compare between the models. And the traditional way is run the 15 models, okay, and then manually, copy and paste the results. If you're interested in the model fit, likelihood value, AIC values, BIC values, okay, copy and paste from the 15 results and then compare. Okay, but integration with the R, you can totally eliminate that process, and then you can just write a code to gather all the information from the 15, whatever the number of the analysis, and then create a table right on R so that you can compare. So it will eliminate mistakes, which we are very likely to make, when we do the copy and paste, and also time, to do the copy and paste. So anyway, so that's the what I focus, but I figure out that not everyone has M plus, so I decided not to use M plus, but if you're seriously considering pursuing analysis, SEM analysis, I highly recommend you obtain a copy of the M plus. Okay, it's not cheap, but it's worthwhile. So academic pricing is that for non-student, academic pricing is about $1,000, and then they charge $175 to renew annual license. But if you're a student, they have a good deal, and about $300. It's a one-time payment, and then you don't have the upgrade, right? To upgrade the version, but if you pay $300 one time, and then you can use the copy for rest of your life. Technically, the rest of your life. But of course, it will be updated in a few years. But that's what they offer. Okay. But today, as I said, I'm not going to use M plus, but I use the one well-known package called the lavaan. Okay. Which is designed to do the SEM, structural equation models. Okay, lavaan actually stands for the I forgot, but L for latent, okay, latent variable, and the latent analysis, something like that. Latent. Here you go. That's it. Yeah, latent variable analysis. Yeah. So that's what the lavaan is. Okay. All right. So, it's almost impossible to cover everything about SEM. So I picked two good application of the SEM. One is the mediation analysis, which is the application of the one form of the SEM called the path analysis. And the other example is the measurement invariance test, which is the application of the confirmatory factor analysis. So those are two examples that I chose to present. Okay, and hopefully I can cover both.
Does it do modulated mediation?
Yes, not by lavaan. Well, you can write your own equation. Yeah, you can write. As you know, for those who know what the moderated mediation is, when we say moderated mediation, mediation effect depends on the another value of the another one variable or something like that. So there, when we talk about the moderated mediation, we have to figure out, okay, what is the equation for the mediation effect? Mediation effect is a function of the one variable in a model, typically a moderator, or it could be the predictor. Okay, so if you know that equation, if you can derive an equation, yes, you can use the lavaan to do the moderated mediation. Yeah. Yes.
This package assesses fit as well?
Yes. Yeah. Mm-hmm. All right. Any other questions? Okay. And the lavaan has the website. So, it has also tutorial. So I highly recommend that you go to that website and learn more, beyond what I talk about today. Okay. But again, if you're very serious about structural equation model, I highly recommend to go for M+. For example, moderated mediation that we just discussed, M+, most of the cases, we don't have to know the equation. M+ will figure out the equation, then it will do the analysis pretty fast, actually much faster than the lavaan does. Okay. All right, so let's take a look. Okay, so maybe I will make it a little bit bigger. Oh. Okay. Okay. All right, so the first example is the mediation analysis. Okay, but notice that what packages I loaded. One is a tidyverse, to do the data manipulation and the use of the pipes. Okay, and the second one is the diagrammer. Yeah, okay, that's a combination of uppercase and lowercase, and the wherever author of the packages we like to have the R at the end of the name of the package name, so that the you can name in something like this and it looks cool. But anyway, so this is the sort of the sidetrack, but this package can draw pretty cool diagram actually. Okay, so I thought that it is interesting to let you know. And then the third one is the lavaan. Okay, and then the last one is called the SEM tools, which actually help, which is a helper package for lavaan. Okay, so it is a sort of add-on to lavaan package. Okay. All right, so the first mediation analysis. So this is not a moderated mediation, but I have actually, the example HTML file that I showed you in the beginning of today, that file was actually about moderated mediation, actually. I can share that with you, actually, if you like. All right, so read the data. Okay, so I use the data file available from the M+ website, actually. So I'm using lavaan to use the example data from M+ website. So they may they may be mad at me, but they made it publicly available, so it should be fine. Okay, so here is the data description. So data are from the sex discrimination study, where subjects were presented a story of how female attorney lost a promotion to a less qualified male due to discriminatory actions. Okay, subjects were randomly assigned to two different scenarios. One, the female attorney takes no action, and two, the female attorney protests. Okay, so it is an experimental study. But variables that of the interest is the intervention variable, that is the predictor, or sometimes called the exposure variable in the mediation literature. In this case, no protest is coded to be 0, and the protest group is coded to 1. Okay, and outcome variable is the how well the subject liked the female attorney. Okay, and the variable is the named liking, and that is the outcome variable. Okay? So depending on the which group subjects were, interest was that the how subjects will like the female attorney, well, how much the favorable impression that the subjects will have to the attorney. Okay, but the researcher in the original study hypothesized that there's a mediator for the relationship between those two variables, which is perceived appropriateness of the response of the female attorney. So how appropriate each one of the subjects think about the female attorney's action, that will mediate the how they like the attorney. So that is the a little bit of background. Okay, so in order to read the data, so okay, the data file is the protest.txt. That's a text file. Okay, so that's the another kind of file that the we haven't looked at it, but it is basically M+ prefers always the what is a fixed column format with the basic essentially space delimited. Okay, and to read that kind of the data file, it is suitable to use the function called read.table. Okay, and then since the data file actually didn't have the variable names, actually that's how the M+ works. I don't know how they made a decision like that, but that's how M+ works. Okay, so I'm giving the variable names. Actually, original data had the 4 variables in addition to the 3 variables that we are going to use, which in the first one is the one, actually, sexism. That is another variable that we have in the data. Okay, but we are not going to use that. But liking, response appropriateness, and the protest. Okay, those are 4 variables in the data file. Okay, so here is it. This is actual data. 129 subjects and 4 variables, and you look like that. Okay, and again, this is an interactive table, so we can scroll down like this to see the data. Okay, all right, and here's the descriptive statistics. So I always do this to run the quick descriptive to get the idea of the how the data look like. Okay, mean, standard deviation, minimum and max, and the range, and the last one is actually standard error for the mean. So it's not that informative, but the others are quite helpful to understand the data. Okay, model. Okay, as I think I mentioned, but our interest to investigate an effect of the intervention variable protest to the outcome variable liking. However, it is suspected that effect is mediated by perceived response appropriateness. Okay, so graphically, this is the model that we want to investigate, and of course, the mediation effect is the multiplication of the this path and this path. Okay. Any questions? Okay, if you are new to structural equation model, actually this model represents the a set of the two regression equations. Okay, so one is the y liking as an outcome, and those two are predictors because that's how those arrow works. In a diagram, when you see the arrow comes out of the one variable to another, it means that the variable where the arrow is coming out is a predictor, and where the arrow is go in is the outcome. Okay, so liking, there's two arrows coming into that variable, which means that the liking y is predicted by two variables, which is the response appropriateness and the protest. And another outcome variable is the response appropriateness. Okay, so there is one arrow coming into that variable, so that indicates that that variable is the outcome variable. Okay, and then in this case, protest predicts the response appropriateness. Okay, so that's how the structural equation model works, or path analysis works. Okay, is it clear? Okay, good. Okay. Oh, by the way, this diagram has been written by a package called the diagrammer. Okay, so if you're curious about code, you can go to the .rmd file and you can see the code.
But there you have to specify where the diagram are going to go.
What's that?
So there you have to specify the positions of the diagram. So it's like a graphic program. So you write position of each variable. If you don't write them, does it come on top of each other?
Well, if you don't specify the position, they will use the default positions based on the number of the variables you have, and then typically it doesn't come out in a way that you want to see.
Is
Yeah.
it like the visceral diagrams?
Pardon me?
The visceral diagrams that are kind of mushed into each other? Does it look like that?
Could be. I didn't try out for this particular case. Yeah, but I have seen a case where the arrow is not really straight, like a curved arrow like that, and yeah. But you can play with it, if you're curious. But in order to write the path diagram like this, I believe that it is a good idea to give the position, exactly the position. Okay. Okay. So specification for lavaan. Okay, I think I can make it a little bit bigger. All right, here you go. All right, so this is the way we specify lavaan to write out two regression equations as well as the defining the mediation effect. Okay, the first line here, okay, it says liking tilde and then B1 asterisk and response appropriateness plus protest. Okay, so there are several components I need to explain. One is the this tilde. Remember when I was showing the regression and the logistic regression, outcome variable and the predictors were basically connected by tilde. That's the same idea. Okay, and then the next one is the this part. Response appropriateness plus protest. Again, that is the same idea as when I did the regression and logistical regression. Okay, essentially those are list of the predictors and then using plus to connect them, just like they write in the regression equation. Okay, all right, and then the last component is the B1 asterisk. Okay, what is it? Okay, I did this because I wanted to label a parameter based on this variable to be B1 because I want to create the new variable which will be the mediation effect later on. Because remember, when I was showing this diagram, mediation effect is the multiplication of the this path and this path. Okay, so which means that we have to create the another parameter, which is a function of those two parameters. Okay, so if the purpose is just fitting this model without estimating the mediation effect, we didn't have to do B1 times here or G1 times in here. We just say liking tilde response appropriateness plus protest. That's it. But since that I want to multiply the slope for the response appropriateness and slope for protest for the other equation, that's why that I need to label those two. Okay. So this is the Lavaan's way of the labeling the parameters. Okay, so in this particular case, the labeling the regression slope. Okay, so essentially, okay, provide the label. Okay, in this case, I say B1, but it doesn't have to be B1. Okay, just like the variable name that I was talking about, you can label any parameter you want in in any way you want. Okay, just like your child. Okay, but I thought that the B1 is the convenient enough. Okay, and same thing for this G1. Didn't have to be G1, but this is my choice. Okay, and then put the asterisk right before or in between that label that you want to give and the variable. That's how Lavaan understands our intention. Okay. And then, okay, the second line is obvious, right? This is another equation, where that the response appropriateness, which is a mediator for the model, is predicted by the protest, which is the intervention variable or exposure variable. And then that slope is now labeled as G1. Okay. The third line, this is where I define a mediation effect. Okay, mediation effect is again simply the multiplication of the those two paths. I label this path as a G1, and I label this path as the B1. So what I need is the G1 times B1, or B1 times G1, doesn't matter, or order doesn't matter. I don't remember how I did. Oh yeah, B1 times G1. Okay, so this is the new parameter. Okay, but new parameter we have to label. Okay, this is a label I gave for the new parameter. I say prolix. Well, actually this is a combination of the three first letters of the each variable. Actually, maybe I had a better way to name, but again, this is your choice. This was my choice to label the new parameter. Mediation effect parameter. Okay, and then the keyword here or operator, to create the new variable is the colon and equal sign with no space in between. Okay, don't ask me why. This is how they decided to do. Okay, again, I'm just following their rule. Okay, but that's the combination of the two characters to be used for the defining a new parameter. Okay, that's it.
How about the apostrophe, the before and after the three iteration? That there's the apostrophe,
Oh, the one I highlighted here.
not that there, not that.
Oh.
Oh.
Oh, we mean this single quotation?
Yeah.
Okay, all right. Okay, so this is essentially the intention is that we are creating the text information. Okay, so object that I'm creating here, ma.mod01, is that object which consists of the text. Text is simply the Lavaan syntax. Okay, so on R, all the text information is comes with a quotation, either double quotation or single quotation. Okay, so I could have actually used the double quotation here. It will be the same thing.
So that actually, when we learn that, in on the R studio, we have to delete that apostrophe, right?
No.
No.
No. This is needed. This is needed, and also closing quotation is needed. I hope I'm answering your question.
I got an error. I just copy that one and then.
Oh, I got it. Okay, so if you just copy the this quotation mark, there are many different kinds of quotation mark. I don't know how many, 2 or 3. Okay, so this quotation mark has to come from the key. Well, on Mac, are you using Mac?
Yes.
Okay, so in that case, that has to come from the just right by the return key. Okay.
Okay.
Yeah. Otherwise, if you just copy and paste, it may copy the different kind of the quotation mark actually. Yeah. So that's something, yes, I have encountered as well. So especially, if you copy from the quotation mark from the formatted text, like the Microsoft, software, for example, they will automatically change the quotation mark in a certain ways, and that is not the same quotation mark as the what we have on the key, actually. Yeah.
But once I log in, still on the bottom, under the console, it asks me to add some more information. I have to cross line and then the cursor. It sounds like I need to add more information.
Oh, after this or? Okay, let me show you the actual. Okay, so this is what I have, for our markdown file. So are you doing the analysis on the R script file or R markdown file? Script? Okay. All right. So if you copy exactly from the my R markdown file, it should work. But if you copy from the HTML file, it may screw up. Yeah. Okay, so let me run here. Okay, so load the library and read the data. Okay, run the descriptive model. Okay, so this is the diagrammer syntax. Run it. Look like this. Okay, here it is. Okay. Specify the lavaan syntax. Like that. No error. Okay.
No error, no output.
What's that?
No error, no output. Well, I'm assuming the next chunk of code will give us output.
Oh, the reason that you don't get output is that the output has been stored as the output object.
Yeah.
Okay, and then you run summary function to see the actual summary output. Yeah.
Which is the next
Okay, and then run. So it takes a little bit of time because that it runs the bootstrap iteration. Just to let you know that in mediation analysis literature, it is highly recommended to run the bootstrap rather than using the traditional delta method estimation of the standard errors, because it is quite obvious that the sampling distribution of the mediation effect is asymmetric, not symmetric, so that it is inappropriate to use the normal approximation of the sampling, symmetric sampling distribution to obtain the confidence interval. Okay, so confidence interval should be obtained by the empirically obtained the bootstrap sampling distribution. So that's why that I'm running bootstrap, and it is highly recommended to do that. Okay. All right, and after running it, Okay, so again, results are stored in this object. Okay, I can take a look here. Okay, this is not small object anymore. Okay, so if I go to environment, and this is the what is that? Yeah, this is it, right? So here, yeah, this is quite sizable uh, object. So it stores a lot of information about the model, data, and the results, and also process of the estimation as well. Okay, and fit information is here too, as you asked. Here's the section called the fit. Yeah, but if you want to extract the fit information, you use the strategy that I mentioned earlier by using dollar sign. So in this case, ma.fit01 dollar sign and go to fit. And then it will come here and then see what they have. Oh yeah, so under this, it has a lot of the fit information underneath. Okay, but it's always a good idea to look at the summary results. We can use a summary function, and actually summary function is not specific to lavaan. It is a more generic function based on the base R, but those package developers, create those output objects such that the summary function will produce what they want people to look at. So the lavaan developers did pretty good job in terms of the designing the output object so that we can use the summary function. Okay, and actually it will produce the output just like M plus actually. If you have ever seen the M plus output, they almost look identical. And actually, M plus people consider suing lavaan developers legally. Yeah, and story is that they sent a letter to lavaan people, but the lavaan people were sure that it doesn't violate the copyright, because that it's just the output, not the inside of how the parameters are estimated. So they responded in that way that the M plus people sort of gave up, pursuing the lawsuit. Yeah, so that's a little bit of sidetrack story. But here, it contains the information about estimation, maximum likelihood estimation, and yeah. Oh, okay. I forgot. One option you can get is actually under summary. You can say fit equals to true. Okay, and then that way, you will see the fit indices that you typically evaluate. Okay, so let me rerun, and then you will see for those who know about the fit indices, you will see. But however, in this case, actually, this is okay. How many degrees of freedom? Oh, this is a saturated model, so it is still useful. Okay, so there's 3 degrees of freedom, so that's good. But this is perfectly fit, actually. What about the chi-square? Chi-square, chi-square. Where's the chi-square? Log likelihood. Do you see chi-square? I don't see chi-square. Oh yeah, here. Yeah, this is the chi-square. Yeah, chi-square is 73, so it's meaningful. Okay, and the other fit indices, perfect fit for CFI TLI. So for example, CFI is a very popular fit index, which almost always people report. And another popular fit index is the root mean square error approximation, or some people say the Ramsey. That is the another fit index that people usually report. Okay. All right, and the AIC, BIC, those can be used for model comparisons, but in this case, we are not that interested in this. Okay. All right.
Dr. Tom,
Yes.
you said that R can handle smaller sample size. How does that
More or smaller?
They can handle smaller sample size. Is that,
Oh, did I say that?
I don't know. I'm
Oh.
trying to clarify.
Oh,
Because
what-
SEM, you need a certain sample size.
Well, I don't know which comment you're referring to, but if I say so, probably you misinterpreted it. But yeah, I don't think I said that the R can handle smaller sample size. Did I say that?
I don't know. That's
Yeah. Well, lavaan is just a one software product to do the SEM. So sample size requirement doesn't change from the other way of the fitting the maximum likelihood for the same model. But if you use the Bayesian approach with the informative priors, smaller sample size may do a good job, better job. Yeah. Did I answer your question or?
I think so.
Yeah. But sample size is something that you can investigate with the power analysis. Yeah. Just like the app that I showed, at the beginning, that is for moderated mediation. But in order to do the power analysis for this simple mediation analysis is not that difficult. But you still need to do the simulation-based power analysis by running the many times. Same generate the data and fit the model and the investigate the statistical significance for target parameter. Many times, like 1,000, 2,000 times. Yeah.
Yeah, I guess where I was going at was that if you're using ANUS, for example, that's going to require a minimum amount of sample size to look at the relationships of the latent constructs. But for something like PLS SEM, they can handle a smaller size. I guess I was looking
SEM or maximum likelihood?
Yes, for in ANUS. Yes.
Well, AMOS, I don't think the AMOS is doing something different from the what lavaan does. And sounds like I never did the analysis with AMOS, but sounds like AMOS has the different option for the estimators. Like a penalized maximum likelihood. That's what I believe you said.
Yeah, and you need a sample at least 200 or something to run the model.
Is that what they said?
Something in PLS, they can manage a much smaller sample size. So I was just curious about what's R for SEM.
Or for lavaan?
Or yes.
Well, for sample size, first of all, personally, I'm very hesitant to say that, okay, this is what you need in general. Okay, so sample size requirement is the very situation specific, depending on the parameter values, depending on the model, depending on the specific model, on the specific set of the parameters. Okay, so even with this simple mediation model, I don't think that it is a good idea to advise people that you need about 100 observation to fit this model. I think that is a very wrong practice. Okay, that's one of my opinions, and but if you want to come to that conclusion for that question, what it does is lavaan does is fitting the very straightforward maximum likelihood. So look into the literature and what people recommend to fit this kind of model with the maximum likelihood, and that's it. That applies to this situation too.
Yeah, PLS is using partially squared, so that's a different method. That's the reason it requires less sample. Oh, this is maximum likelihood.
Right. That makes sense.
Oh, partially square. I don't know what that is. I thought the penalized maximum likelihood. Yeah, But sample size, you have to do the power analysis if you have a very, definite answer. And again, n plus, in order to do the power analysis, you have to code to run the same analysis over and over to do the Monte Carlo power analysis. But the n plus has the certain ways to write the syntax to do the Monte Carlo analysis pretty easily. But on R, you need to write your own code to do the Monte Carlo, simulation-based power analysis. Okay. Hopefully, it answered your question, but there's no definite answer for that. And if you have someone who claimed that something like you need 150, bring that person to me, and I can debate with that person seriously. Yes. Yeah. So sample size requirement depends. So that's why that a lot of people still study the sample size requirement.
Doctor, I just wonder, I really like your summary of the R note about the mediation penalty for penalty. I wonder if you have the summary of the moderating penalty, penalty in R notebook that you can share with them.
Okay, I have the similar document for the moderated mediation.
Yeah.
Yeah.
Can you share that, the documentation?
Yeah, I'll be happy. Yeah, so I can upload to the GitHub, later on.
And also,
Yeah.
if you have like the comparing the model, like the full model and nested model, if you have that, documentation as well.
Oh, model comparison.
Yeah, model comparison.
Oh yeah, I do. That's what I teach for my SEM class. So, yeah.
That'd be great.
Yeah. Well, if you invite me here for a semester, maybe I can teach a full class.
Please don't give us idea because we will happen.
How about online call? Online call, you can register your own.
No, we check.
Oh, really?
Okay.
So now we have a full mediation or a partial mediation? We have full mediation.
What do you exactly mean by full versus partial mediation?
So the direct link from
Okay, let me. Yeah.
Is the direct link still significant from protest to liking? So if it's not, that would be a full mediation, right?
Oh, okay. So you're talking about a variation of the mediation effect.
Yeah.
Okay. So I actually really didn't get serious about evaluating that part. Okay. So I was so focusing on the procedure. Okay. So.
Protest is insignificant.
Yeah, but significant. But this is based on the estimated bootstrap estimated standard error, and then computing z-value based on it. But my point here was actually we need to really evaluate the asymmetric confidence interval. So that's what I have here. Extract the model parameter estimates and the 95% confidence interval. So if I run this part, here you go. So confidence interval, lower band and the upper band for each one of the parameters, including this newly created mediation effect. Okay. So here's the lower and the upper bound, and it's quite clear. 0 is outside. Yeah, so the decision doesn't change, by looking at the results in here, but more correct way to interpret is based on the confidence interval. So does it make the full mediation? Yeah. Okay. Yeah. Well, I wasn't familiar with that explanation, so yeah. Okay. Yeah, and then direct effect was which one is the direct effect? Like, yeah, this is the direct effect, right? Yeah. So this is a direct effect and the non-significant. So, yeah, for mediation, yeah. Mhm. And also, if you're interested in the standardized, those are the non-standardized coefficients based on the original scale. And then standardized coefficient can be extracted by function called the standardized solution. That is part of the lavaan. And then with a little bit of the control here, I say I want confidence interval. I want the 95% level, 95% confidence interval. And then I don't want this, that, and I don't want the p-value to make the table a little bit more concise. We can do the same way, and the conclusion stay the same. Okay. All right. Any questions? So that is the example of the mediation effect. Yes.
So, for example, I'd like to open a new project for this SEN analysis. So does that mean that I have to create, or is it advisable that I have to create a new folder?
Yes. Exactly. Yeah. Create a new folder, and let's say something like mediation 01, or mediation 99, or whatever, and then copy the data file, and then either start with the R script or R Markdown, R notebook.
So in your script, Dr. Kamata, you said there protest.dat in the lesser sign, then read.table.
Yes, yeah,
and
two.
In your parentheses, you have the quotation data. So should I change that word?
That's right, yeah. Because that arrangement is based on the how I had the data file. I had a subfolder called the data, and I put all the data file into that folder. So, yes. Okay. Oh, sorry, I moved. Okay. Any other questions? Okay. All right. The next example is measurement invariance test. That's that is actually the application of confirmatory fact analysis, but at the same time, it is the application of what is called the multiple group analysis. So when we say multiple group analysis, we are fitting the same model for the two or more groups simultaneously. Okay, and then we control, which part of the model parameters are the same or different, between groups. That's the basically how the multiple group analysis work. Okay, so specifically in the context of the measurement invariance test, we use that basic idea of the multiple group analysis to conduct the what is called the measurement invariance test. So in order to understand the entire big picture about the measurement invariance test, let me go over the different levels of the invariance. Okay, so here this is strictly the hypothetical, and I just used a one factor CFA model with the 4 measurement indicators as the example. But same idea applies in more complex models. Okay, so well, there are mainly 3 levels actually. One is called the configural invariance. Okay, at that level, actually that is the lowest level, where that the basic structure, basic factor structure is the same between groups. Okay, And we don't really assume that any part of the model parameters are the same between the groups, which means that the invariance is only at the level of the factor structure. Okay, so that is what is called the configure invariance. But that is actually, for the purpose of the setting up the baseline model, and it doesn't really mean your data are invariant between groups. Okay, so that is again that is only for setting up the base model. Okay, oh, I just noticed that the oh, there's a still maybe stepped out for bathroom or something. Okay, all right. Okay, so graphically I represent, okay, assuming that there are two groups, but it applies for the more than two groups as well. But any part of the parameters are the same between the groups. Okay, I color coded, and they actually, I should color code those 0 and 0, they're the same, but they are simply the scale constraint. So that doesn't mean that their means are really the same, okay? All right, and then here, factor loadings are different between the two groups. That's why that I have the two subscript. The first subscript for group and the second subscript for the item, okay? And of course, here I have the 1 and 1 for the first item. Because that is a scale constraint. Okay, we need the scale constraint to identify the model for the CFA. Okay, there are two major different approaches for scale constraint, but I use the what is typically done, and actually my preference is the other scaling approach to constrain the variance of the factor variances, but here I follow the more mainstream SEM approach. Okay, and also those size, there are error variances are also different between groups, and also those mu's, those are intercepts, are different between groups as well. Okay, so that's the configure invariance. But again, it's not really invariance. It's just a base model. Same base model applies to the both groups or all groups. And the next level, which is really the what invariance should mean, is that the factor loadings are now the same between two groups or two or more groups. So I now color code it in blue, where the part they are the same. Okay, but factor variances and error variances and the intercepts, they remain to be different between groups. Okay, so factor loading is the representation of the relation between latent factor and the observed item scores. So you can interpret in a way that the metric invariance, this level of the invariance means that the association between latent variable and the item scores are the same between or invariant between groups. That is the interpretation of this metric invariance. Okay, any questions? All right, the next level is called the scalar invariance. Okay, so for this level of invariance, in addition to factor loading, which is the association between latent factor and the item scores, now we assume that the intercepts are invariant between groups. Okay, so that's why that now I have mu's to be blue, color coded with the only one subscript. Okay, the subscript to indicate the group is gone. Okay, but other parts of the model parameters, error variance and the variance for the latent factor and are different actually. And actually for factor means, actually, now we can assume that they're different, actually. Okay, so we assume that the 0 factor mean for one group, but the treat the factor mean as a parameter for the other group. Okay, since we are assuming much fewer parameter for the factor means, intercepts. That's why that we can free up, this parameter. Okay. So factor means, I'm sorry, the intercepts are essentially can be interpreted as the mean factor. Mean item scores. Okay. So mean item scores are invariant between the two groups. Okay. But that is the conditional, though. Conditional on given the same level of the factor scores. Okay. So that is the interpretation. Okay. All right. So usually, we look at up to this level, and I actually have another level, which is a factor mean invariance. But I actually thought, I may not need to present this, but I will present. The reason I was unsure was that at least based on my experience, is quite rare to inspect the factor mean invariance, because the many cases, there are group differences exist on the factor, factor scores for the latent factor that we are interested in measuring, and then unless that you have the claim that the factors, there is no group difference on the latent rate that we are measuring, there is no point to test this. Okay, so
We
you,
want differences, right?
pardon me?
We want differences.
Yeah. Well, it's very dangerous to assume that there is no group difference. Yeah, in many measurement situations. Yeah. So for example, okay, let me come up with the example. Okay, so let's say, educational example for group of the people from education. If you're interested in the latent trait as the let's say reading scores, okay, reading ability, okay, and if you're interested in the let's say invariance of the reading test items, set of the reading test items between gender groups, male and female, okay, although that the difference is quite low, but based on the national survey on the achievement, it is quite clear that there's a gender difference, right? So it's no way that the good to assume that the there's no gender difference, right? Something like that, or is opinion survey, for example. Let's say that the latent trait that you are interested in to measure is the opinion toward the particular political party, let's say. I'm not going to say which, but and then let's say that you are interested in the difference, the invariance of those items to measure opinions on the particular political party between racial groups, right? There should be a difference, right? Overall, some racial group have the different opinion than the another racial group. So in that case, of course, it's not okay to assume that their factor means are the same. Okay. So those are just two examples, but it's very rare, I think, that you want to test this invariance. But technically, we can, in case you are really interested in. Okay. Any questions so far? Okay, so data that I'm going to use to demonstrate is actually part of the lavaan package. This is a very well-known data set that have been used for demonstration of the latent variable models actually. Very old data, but it's still very, very commonly used to demonstrate. Originally from the Holzinger and Swineford, 1939. Okay, very old. Right. The data set is consists of the 301 7th and 8th graders from 2 schools on the 9 items, most seemingly measuring some sort of the intelligence. Okay, and 3 items measure the one aspect of the intelligence, visual ability, and the another 3 items measures the second aspect of the intelligence, textual ability, and the last 3 items measures the last aspect of the intelligence, speed, or capability, or whatever. And then, of course, interest is to investigate whether that those 9 items, with the assumption that measuring those 3 aspects of the intelligence are invariant between schools. Okay, so that is the basically scenario here. Okay, so here the top one, actually this is the another good trick that it's better for us to know. Whenever that we are interested in using the data set that comes with the package, we can use this command called the data, and that will actually load the data from the package. Okay, so since this data set was part of the package, I just said that of course after loading the lavaan, I said data and then the data object name, Holzinger Swineford 1939. That's a very long object name. Okay, and that will load the data. Okay, and then the second thing I did was again run the descriptives to get some idea about the data. Okay, and I always like to use the FAST, but in case you're interested in the other statistics like skewness, kurtosis, and the other things like I don't remember everything, but like trimming. I believe that is the one of the other statistics that you can get if you don't say pass equals to true. Okay. And then next step, what I did was, continuing the running the descriptives because I wanted to see this is just I wanted to demonstrate the use of this function, I guess. Okay, by using the function called the FRQ, apparently that is short for a frequency, coming from the SJ-MISC package, we get the very this type of the frequency table, very close to what you can get from SPSS. Okay, so for descriptive data, for categorical data, this is what I do. Okay, there are other functions like a table, table and the variable name. You will run the frequency, but not the proportion, for example. And then unless you say what to do with the missing data, it will ignore the missing data, so we don't get the information about the missing data without specifying what to do with the missing data. So this provides pretty much all the information. What is the missing data? In this case, 0. Okay, and what is the frequency and the proportion for each one of the categories. So in this case, 145 for Grand White school and the 156 for the pasture school. And the proportion, as you can see, about 50-50, 48% for the Grand White and 52% for pasture, or something like that. So pretty convenient. Okay. All right. So for lavaan, in order to conduct the invariance test, there are two-step procedure. First step is to set up the baseline model. Okay, essentially, the model which will apply to each one of the schools. And then the second step is use the function called well, that's a long name, but here you can see in the bottom, MEASEQ dot syntax. That is the command. I mean the function from the SEM tool package, specifically for the purpose of the measurement invariance test. Okay, so that is quite useful, in my opinion. Okay, all right. Let's look at the baseline model. Okay, very simple. Same procedure. Specify the model object name, and then use the quotations to write out the lavaan syntax. Okay, so what I say here is first line, visual equals to, well, actually not equal and tilde, those combination of the two characters. Actually, that is the combination of the two characters to specify a latent variable in the Lavaan's convention. Okay, so here, my intention is okay, I want to set up the latent variable called the visual, okay, which are measured by x1, x2, and x3. Okay, so it's not really equation because to be more precise, equation for CFA, observed item scores are outcome variables rather than the latent factor. Okay, so it is not really equation, but that it's only the convention that we have to follow for Lavaan. Okay, so each one of the to be more precise, each one of the x1, x2, x3 is predicted by visual, latent variable visual. So that is the more precise way of the writing the equation. But the Lavaan sort of have the convention how to specify latent factor in this way. Okay, is it clear? Okay. By the way, if you're new to SEM, SEM is the really a system of regression equations. Simultaneous estimation of the more than one regression equations. Okay, like a path analysis, it was clear. We had mediation analysis that I presented. It had two regression equations, right? And all of them were observed variables. Okay, but for CFA, actually, we have as many as the number of the items. Okay, the number of the equation is as many as the number of the items. So in this case, actually, we have the 9 equations. For each equation, item is an outcome variable, and then being predicted by a latent factor. Typically 1, but it can be more than 1. Okay. So in this case, actually, each item is only predicted by only one latent factor. Okay, so that's the assumption. But again, Lavaan way of the writing the CFA, we don't write out 9 equations. We write by using this convention. Where it says latent variable name and the list, which items are predicted by the latent variable.
We use equal to and tilde.
Uh-huh.
With other variables that observed variables, we use just tilde.
That's right. Yeah.
So if we are going to write relationships between latent variables, then what do we use?
Only tilde.
Only tilde.
Yes. Yeah. Mm-hmm. Yeah. So equal sign tilde, that combination is only for defining the latent variables. And then to write the regression equations, you use the only tilde. Yeah. Okay. All right, any other questions? So clear? Quite simple, right? So I'm specifying or defining the three latent factors: visual, textual, and speed. Okay, time to test the configure invariance model. Well, not really test, run the model as the baseline model, and then test the next level of the invariance, and if it is supported, further test the next higher level of the invariance. That's how it goes. Okay, so in order to use this long name, name function, well, measurement equivalence syntax, that's how it is originated, I believe. But I don't know how to read it if it is abbreviated in this form. But MEASEQ, no, that's very hard to say. Okay, first we have to say which one is a baseline model. So we use the configure.model keyword within that function and specify the baseline model that I defined in here. Okay, and second, I specify the data object name, and the third, I specify which one is the grouping variable. That is school. Okay, remember when I look at the data? Oh, down.
Right there.
Right here? Oh.
Yeah, there. Brand, white, and pastor.
Oh, yeah. That's right.
There.
Yes. Yeah, that's a variable name. I just wanted to point out the variable name. So thank you. Okay. And then by using the group.equal keyword, we specify that what level of the measurement invariance we are running. Okay, so keyword we can provide is the configure. That is actually part of the list in the SEM tool package. Okay, so we cannot mistype. We have to type exactly configure in this way.
You don't need to know what configurable means actually, because in SEM you have to, like this row, you have to make every phi is equal.
That is true.
Yeah. It does itself.
Right. Yeah. So we have to be careful. Yeah. So for example, like M plus, for example, M plus has the very actually M plus has the even easier equivalent. Yeah, M plus 2. M plus has the one-step test for fitting the configure metric and the scalar invariance in one step. And then, as you say, people don't have to know what they mean. So it's kind of dangerous. Yes, yeah. But, so that's why that I thought it is important to go through this. Okay. But on the other hand, we can say that it's quite convenient, right? Very handy. Okay, and then run the model with the command called the CFA. Remember, for mediation model, we use the function called SEM. But for CFA, there is the specific function called the CFA. And actually, we can still run this model with the SEM, but they claim that if it is a CFA, this function is more efficient. But this level of the complex model, I don't see any difference in terms of the computation time. But if you are running the very complex model with the categorical items, you may see some difference in the computation time.
What if we want to look at the residuals? Is that a separate procedure?
You mean in terms of the invariance between residuals? Well, I'm sure there is the keyword for that. Yeah. Mm-hmm. Yeah.
So just like running this one procedure wouldn't give us the whole output.
Yeah, but we have to go one by one. Yeah, we have to increase, move up to the next level of the invariance. Yeah. So here I didn't include the residuals, but I'm sure the keyword is residual. If not, it should be something very similar. Okay. I can look into it, but let's not do it right now because that the time is approaching right now. Okay, I can stay, after 3:45 as far as I can stay in the room. So I'd be happy to stay for 15 minutes or so after 3:45. Okay, and then run the CFA. Specifying the baseline model here, and specify the data, and specifying the grouping variable. Okay, so in this case, so I store the results in this way. Okay, configure.fit. Again, this is the name I provide, so it doesn't have to be exactly like this. It is the name that you can choose to store. And then you can look at the summary output. Okay, and I'm not going to go over, but you can see that which part of the parameter estimates are the same between the groups, and just to make sure that the what you got is what you intended. Okay, it's important, especially in the initial stage of the getting used to those convenient function not to write out all the models. Okay, let me skip this part. Okay, and then what I did here was the extract the fit indices. Okay, actually there is a command called the fit measures that is also part of the SEM tools. Okay, and then specify the output object name, and then specify which fit measure I want to extract. In this case, I chose chi-square statistics, degrees of freedom, and its p-value, and the Ramsey, and the CFI and TLI. Okay. So under lavaan, you have like 20 different kinds of the fit indices that you can choose from. Okay, but those are pretty much typical. Or maybe I could have chosen the like AIC, BIC as well, but for some reason I didn't. Okay, and then move on to the next level of the invariance. Okay, the idea is the same, so I'm not going to go in detail, but I will point out where the difference is. Okay, so to specify a invariance, now I say loadings. Okay, which means that the loadings are equal between the groups. Okay, and the rest of the procedure is the same. Okay, so I will skip, and then I come to the point that I extract the fit indices. Procedure is exactly the same. Only difference is that the output object name is now metric.fit. Okay, and then I store those fit indices as the metric.fit.idx. Okay, now I will summarize them later on at the end. Okay, and scalar invariance. Okay, so everything is the same. Of course, I put the different name here, scalar and scalar mod. But now, where I said the group that equal, now I have the loadings and the intercept. Okay, so whenever we have a list of the more than one thing on R, we have to combine them somehow. So that's why that I use the C and the parentheses. Okay, so that C function will actually create the sequence of the values, okay, as a set, which is called the vector in the jargon of the R. Okay, which is different from the vector in the matrix algebra. So it's kind of confusing for those who know the linear algebra. But that is what it's called. But it is a sequence of the values as a set. That's what the this C function does. Okay. All right. And then again, the rest of the procedure is the same. And then I summarize. I extracted fit indices, same set of the fit indices. And also I did the factor mean invariance. The keyword is mean. So now I have the 3 keywords indicating that the loadings, intercept, and factor means are the same between 2 groups. Okay, and then went through the same procedure, and then run the model and extracted the fit indices. Okay, all right. So now I run four models, right? So I will combine fit indices from the 4 models by using the R command. This is not a function from the lavaan or SEM tools. It's this base package command called the rbind. Essentially, rbind means that the combine rows. Okay, since that the fit indices has been extracted as just a series of the values. Where it's 6 values for each one of the models. I can combine row by row to make the nice table of the output. Okay, the result is like this. Okay, so yeah, it didn't fit in the one what is that? One set of the rows, but the results are here. So those are chi-square and the degrees of freedom, okay, and the fit indices, okay, and then what we are supposed to do for measurement invariance test is the at least 2 things. One is the chi-square difference test. Test whether that the higher level of the invariance is supported as opposed to the immediately one lower level of the invariance. So for testing the metric invariance, where we assume only the factor loadings are the same between the groups, we compare to the configural invariance model. So in order to do that, we can use the ANOVA function. ANOVA function is the base R function, and then it will do the chi-square difference test just like this. Okay. So I say ANOVA configural.fit. Remember this is the output object. When I run the lavaan by using a CFA function. Okay, and also metric.fit. Okay, that is the output object for the metric invariance. And then if I list those 2 models that I want to compare in the parentheses for the ANOVA function, it will do the chi-square difference test like this, and then also it extracted the AIC and BIC values like this. So very convenient, right? So no manual comparisons. Okay, so that's the beauty of R.
Well, what if I want to see what is different?
What is?
What if I want to see what is different in the model? So which variable is the one that is causing the difference?
Oh, okay. So now you're talking about the partial invariance.
Yeah.
Yes. Yeah, that'll be next step.
Okay.
Yeah. So, but in this case, since the result shows that the based on the chi-square difference test, okay, less restrictive model, okay, which is the configural model, didn't improve more restrictive model, which is the metric model, right? Which means that we prefer metric model, okay? So in the model where all the factor loading the same are supported, which means that the metric invariance is supported. So full metric invariance is supported. So which means that we don't have to look into the which item causes the non-invariance in this case. Okay, but if metric invariance is not supported, yes, then we need to go into the which item is causing the non-invariance. Okay, so actually this happens when we evaluate a scalar invariance. Okay, so now I'm comparing the scalar invariance to the metric invariance. Okay, if we do, actually, p-value is very close to 0, which means that more metric, metric invariance model is the less restricted model. Actually improves the model fit statistically significant compared to the more restricted model, which is the scalar invariance model, which means that the scalar invariance is not supported. Okay? So in that case, yes, we are interested in.
To know what is causing.
That's right.
Scalar variance.
Exactly. So, this is the end. Okay, I didn't have the partial invariance. Yeah, I do have the results actually. So I can tell you verbally, okay, what's the next step? The next step is I would look into the modification index from the scalar invariance model, okay, which tells you, okay, which part of the parameters can potentially improve the model fit, okay? And actually, modification index is the chi-square value, which will reduce if the one particular parameter is included in the model. Okay, and then if you can spot any of the intercept parameter in this case to be different between the groups, then that would be a candidate for the partial invariance. Okay, so in this case, actually, as I remember, item 3 and 7 are candidate for non-invariant between the groups. So I specify that okay, those two items are not invariant, and then fit the model and compare to the again metric invariance. Okay, so actually. I do have that. Okay, I know that the time has passed by 5 minutes, but let me pull out. This will be the last slide because I do have that result. Okay, from my. Yeah. Yeah, here you go. Partial scalar invariance. So in addition to the group that equal specification, there is the another specification group that partial. And then this is a way that the intercept for item 3 and item 7.
You set them free.
That's right. Yeah, those are those two parameters are going to be freely estimated, for two groups. Yeah, and then actually this is the again lavaan way of specifying a intercept. Variable name and single tilde 1. That's the lavaan way of the specifying the intercept. Okay. All right, and if you do. Okay, and then going down to the model fit, and then, okay, I didn't do the chi-square difference test, but yeah, so as you can see, the chi-square difference is quite small, 5.4 with the degrees of freedom equals to 4. And remember, if you are, if you learn the statistics from the table from the back of the textbook, critical value for the chi-square statistics for degrees of freedom equals to 1 is 3.84, right? Yeah, I still remember that value. Okay, so with the 4, I don't know what the critical value is, but the should be larger than 5. Okay, so in this case, actually, I did the manual chi-square difference test and it is not significant. Okay, and then also another criteria is the CFI difference. Okay, CFI difference improvement is the less than 0.01. It is considered as the improvement is trivial. Okay, so in this case, from the partial scalar 0.919 to the 0.921, the difference is like a 0.002 or 1 or 2. So
RBCA got better.
yeah.
RBCA got better,
So in this case, evidence is plenty that the partial invariance is supported. So which means that the item causing the problem are those two items. Yeah. So that's the procedure that the you may do if you are doing the invariance test. But this case, two groups are easy. Okay, but if you have more than two groups, you have to test. Okay, when overall invariance test fails, okay, you have to test. Okay, which group is different from which groups? So that will cause the a lot more comparisons. Okay.
to do them twice separately, two at a time.
There are two approaches. Just like the ANOVA test. After the omnibus test is rejected. Either we look at the pairwise comparisons or that the contrast, right? So you can do it in either way. What I have done in the past is the pairwise, but my colleague said that the at the SMU said she prefers the more like a contrast, one group versus the others. Yeah. But I think either will be fine. It's just like the omnibus, traditional ANOVA test. After the omnibus significance is found. Yeah. Okay. So I think that's it. Any questions?
We'll email you. Right now.
Okay. All right. So I will stop the recording first. Okay. Let me stop the recording. Okay, now I don't know how to stop the recording. Okay.
Well, on behalf of the School of Education research program, as well as the College of Business and Economic Development, we would like to thank Dr. Tomasa for sharing his expertise on art in our studio during this very informative workshop. We would also like to thank all of our attendees for your support of our workshop. Finally, we would also like to thank Judah for his leadership in organizing this workshop as well and inviting Dr. Tomasa to share with us.
Well, thank you. Well, thank you for coming, and I really enjoy presenting my material. But please let me know if you have any questions, and please email me. My email should be on the slide. If not, ask Jude.